Hey guys, it's Booth Dog again. Here we are at the start of our second week of this new experience for us all. We certainly live in interesting times. Um, I'm grateful to be experiencing this with so many great people like yourselves. Just please, I'm going to keep saying this, but especially as this continues longer and longer, just reach out. I'm here if you need anything. Many of us are, okay? Um, Now, to lighten the mood a little, I know many of you have been asking about a house tour, so I thought, why not? So let's go ahead and get started before we bring Mr. Boothman on to give you your lesson for the day, okay? Here we go. All right, good morning, everybody. Let's go ahead and jump in. So this is our second day on lesson 7.3. It will be our last day on this section. We are going to end up skipping the rest of the notes for this section. The second learning target here was italicized. That means it is what I deem non-essential anyway. It's more applications of the dot product for reasons that we would have gotten into in 7.4. It's nothing terribly important. It's not included on your final, and it'd just be another extra couple of formulas for you to memorize. So I'm going to skip that for now. You, of course, feel free to look through the notes if you are interested. It's about taking a vector and talking about the component of the vector that's in the direction of another vector, or actually taking the vector and doing what we call a projection of that vector onto another vector. So it is kind of interesting, especially once we start applying all of this to different real-world situations, but I'm going to go ahead and jump past that for most of you. Your exit ticket today will be graded. It is on lesson or learning target 7.3a. So it's what we started on Friday. Today we're going to do basically some practice. Okay, so throughout this video, go to a slide, pause it, try it yourself, and then restart the video, or yes, play the video, and I'll show you how to work through it, and then you can compare your answers. All right, so let's talk about finding the dot product of v and u. Okay, so dot product here is going to be 2 times 2 plus -1 times 5. Now, many of you keep asking me, what do you have to memorize? You do need to know the dot product formula. It's not a difficult formula. The angle between vectors formula is given to you on the reference sheet, but this dot product formula is something you need to know yourself. And now we simplify, and we get the dot product is -1. Okay. Now, a great question, especially for those of you who are actually paying attention to these videos, I would listen up, because this seems like a question I'd put on the exit ticket, perhaps for a highly proficient score. Is v dot u the same thing as u dot v? That's an excellent question, and it turns out that they are the same. And the reason for that is if we do u dot v for the same problem, okay, 2 times 2 plus 5 times -1, okay, see, all we did was change, it's kind of hard to tell for the first one, since they're both the same number, but all we did was change the order of our numbers as we were multiplying. And as we all learned many years ago, multiplication is commutative. So we're allowed to move the order around and our answer remains the same. So is the dot product commutative? Yes. V dot u is the same as u dot v. That will always be true. Okay. So definitely something I'd ask on an exit ticket. In that exit ticket, in fact, I believe I asked why or why not the dot product is the same no matter the order. If you're watching this, go ahead and just put, because Mr. Boothman said so in the video. That's fine with me. We'll see who's not paying attention to these videos. So let's keep it here. All right, find the dot product. Again, pause this and then come back and check your answer with me. U dot W, 8 times -3 plus 2 times 7. Okay, so we have -24 plus 14, or -10. Okay, so dot product, very straightforward. Hopefully we're not having too much difficulty with this. Let's talk about the angle between two vectors. So find the angle between these two vectors, vector u and vector w. Now this formula is given to you on the reference sheet. Cosine of the angle between two vectors equals their dot product all over the product of their magnitudes. Okay, so let's find u dot w. This is 8 minus 9, or negative 1. The magnitude of vector u is the square root of 2 squared plus negative 1 squared, or the square root of 5. The magnitude of vector w is the square root of 4 squared plus 9 squared, which is the square root of 97. So plugging all of this into our formula, negative 1 over the square root of 5 times the square root of 97. You can combine this if you want into a single radical. We're multiplying it all together anyway. We're going to take the inverse cosine of all of this. So we're throwing all of this into a calculator as it is. Whether you want to combine it and then have an easier time plugging it in here to the inverse, or you just leave it all as it is and throw all of that into the inverse function, totally up to you. Here we get an answer of 1.62 radians, or approximately 92.6 degrees. Okay, so on your exit ticket, I will be specific whether I'm asking for radians or degrees. Just make sure whatever calculator you're using, you're in the right mode. Okay. Let's do one more practice problem, and then you should be pretty good to go for your exit ticket. Find the angle between these two vectors. All right, so cosine of the angle between them is u dot v over magnitude of u times the magnitude of v. So we find the dot product first. Negative 11 minus 8 is negative 19. A little more unpleasant than we're used to. That's okay. The square root of 137. And the square root of 5. So we plug all of this into our formula. And we take the inverse cosine since we're solving for that inside angle. Be very careful when you plug all of this in. And we get theta is approximately 2.38 radians, or 136.5 degrees. All right. That really is all that I have for you in this section. Okay, so if you've watched this, you got these answers correct, you should be pretty good to go for your exit ticket. Go ahead and spend some time taking that. That will be due by midnight tonight. We will spend the next few days looking at section 7.4, where we apply our vector operations and formulas to real-world situations. Continue practicing with the rest of this unit. We will be taking this unit exam next week on Monday. Okay, so we'll review the unit on Friday, unit exam next Monday. So make sure you're practicing. Please join our Google Meet. Reach out to me if you have any questions or concerns. Thank you. All right, well, I hope today's lesson was entertaining for you, was interesting at least. Please do your assignment. You know, it's kind of obvious when the view counts on my YouTube videos are lower than the number of people turning in exit tickets. So, you know, watch the video before you just submit a question for the day. You know, we will be doing unit exams in the coming weeks, so you are responsible for this. These are real grades. This is your grade. You are getting credit. So keep on top of everything, okay? Reach out if you need anything. Otherwise, take care. Wash your hands. Be safe. Like and subscribe.